Hello! I'm your dizzy dude, Adam Tilted, and welcome to Orbit at a Tilt, known as the best science show on Facebook. So says Bob, so it must be true. Last week we talked about Einstein and Newton and their competing theories on what gravity is. And we also talked about the experiment during the solar eclipse of 1919 that that proved that part of Einstein's theories were correct. So today we're going to build on that and talk about a phenomenon called gravitational lensing. But first off, I want to show you some sky watching stuff. So let's switch over to the planetarium. Okay, so this is tonight at just after dark, and you can see Venus. We still have a great view of Venus, and Venus has been in the constellation of Gemini. This is Castor and Pollux. So as we go forward in time towards the weekend, you can see Venus is passing out of Gemini on the 8th. It will be that's its closest approach to Pollux, which is the star here. Castor and Pollux, the twins of Gemini. So remember to take a look at Venus. Jupiter is also high in the east. Swirl over here. Okay, where's Jupiter? Okay, Jupiter is not up yet. So we'll move time ahead. After it gets good and dark, we see Saturn. So this is a great time to look at Saturn through a telescope because the moon is not close to it. And it will be high in the sky for most of the night. So let's see, what time are we at? This is 11. And then, I don't know where my Jupiter is. Did I miss it? There's Mars. I must have missed Jupiter. But you'll see Jupiter. It's big and bright. Venus will be that bright object in the west, just as the sun goes down. Jupiter will be a bright object overhead during the night. Saturn will be not quite as bright, yellowish. Mars is even less bright and has that reddish tint. So go out there if you have clear skies. It's getting warm enough now to go out at night and look at the stars. So see if you can spot those planets among those constellations. Okay, so today, gravitational lensing. Remember last week I showed this demo of the sun. This was modeling the sun during the 1919 eclipse and how it distorted the image of the stars and objects behind it because the sun, the sun's mass creates a curved time in space. A curve in space-time. And that was a prediction made by Einstein. And so that experiment proved that part of Einstein's theory correct. This theory, we've now seen this on a bigger scale. As our observing equipment has improved, we have things now like the Hubble Space Telescope, which are above the interference of the Earth's atmosphere. And we have found lensing in space, like in real situations. Let me show you that. No, sorry. Okay, so this is an example of a gravitational lens, and it looks like a smiley face, which I think is awesome. So if you look here, there's this is probably 2 galaxies, but the mass, and there also may be dark matter and dark energy here, but there's something massive that is causing the light. Let me see if I can get that. Yeah, you see this smear? That is a distorted magnification of a galaxy that is behind this other galaxy. It's probably that one right there. So this is a neat trick. Once astronomers figured out what this was, then they realized that we can use this as a tool. Here's another one. Check out the distortion on this. I mean, that's an image of one galaxy that's behind this massive galaxy here, and it's just stretched and warped around. Then we have the Big Daddy. This observation is amazing to me. Let me see if I can make it smaller. Yeah. So the gravitational lensing is happening right here, and you can see some distortions here, here, here. And if you know what to look for, you can see some duplications like this, and that, and that, and that. So, you know, you get all of these images that are distorted because the light has been refracted around these other galaxies because of the curvature of space-time. So we have to remember that space does not always travel in a straight line because space is not always straight. So here is an image that illustrates what's happening with gravitational lensing. Excuse me. So here we have a galaxy way back here behind this big cluster of galaxies. And the light from that galaxy is traveling up along a straight path. And when it gets to this part of space, the space is curved and warped by the presence of this massive objects, or could be a cluster of massive objects. And so even though the light is continuing in a straight line from its perspective, it's curving around, it's following that curve of space-time curvature around, which gives us a magnified view by the time the light gets to Earth. That's pretty awesome, because that means we can see galaxies that are too far away for us to see normally. And it's given us a lot of information about galaxies that existed at the very beginning of the universe. Because remember, the further away we can see, the further back in time we are also seeing. So that's gravitational lensing in a nutshell, and I encourage you to do a Google search for it. Do a Google image search. There's a lot of really weird photos, because some of the warping effects are just crazy. And some of them look like a kaleidoscope with the same image. So, you know, go take a look at some of those, and I think you'll enjoy what you find. All right, well, thanks for joining me. It has been a pleasure as always. I encourage you, if you enjoy the show, please share it. Also consider being a sponsor. You can sponsor me 2 ways. You can be a monthly sponsor for as little as $1 a month at patreon.com/AdamTilted. Or you can give a one-time donation to paypal.me/AdamTilted. Please mark it with Orbit at a Tilt so I know that you are donating to the show. That's it for this week. I'm your dizzy dude, Adam Tilted, reminding you to look up. Bye.